Hi, and welcome to our Tech Talk podcast, where we discuss topics across our broad industry, from telecommunications to commercial networks. The most important thing is, if you work in this industry, please join us today, because a crucial part is standards. We've got Dan joining us from Product Innovations. He's going to cover off standards, something we need to know. Dan, welcome back. I'm so glad to see you. Where do we start?
Thanks, Gordon. I'm glad to be here. So we're going to talk about standards a little bit today.
Yeah, please let's share to our audience a standard update. So 2026, What do they need to know?
Well, we'll kick it off because there's TIA, which is one of the groups, Telecommunications Industry Association, that's based in the U.S., but it is an international organization. And then we have ISO and CENELEC and some other groups. So TIA has cabling standards for equipment rooms, data centers, all aspects of LAN cabling. And we meet every 3 to 4 months to go through and kind of keep documents up to date. So it's always looking at what new technologies are coming about and then, migrating the standards forward. So historically, you've looked at speeds going from 1 gig to 2.5 to 5 to 10 gig. And, on copper, we are at, 100 gig. Now we're looking at 400 and 800 gig. So there's always new data rates and technologies coming around. What's interesting, though, is some of the stuff that we work on doesn't start in TIA, but it actually are adopting things that customers are doing in real life. So if you go back a few years ago, we updated the standard to include something called MPTL, Modular Plug Terminated Link. So the standard for TIA for structured cabling required that every link be terminated with a socket, a female socket on each end, a patch panel to an outlet to a wall plate. A lot of people, for various reasons, would terminate a plug at the end of the cabling. And that would be to plug into an access point or a CCTV camera or a public display, information display.
Let's just share that to the audience now. So what's happened is the uptake of IP cameras, digital cameras, and as well as Wi-Fi devices and power over Ethernet meant that people wanted, or integrators installing those types of products, wanted to reduce the amount of connections, not put a patch cord there. So
it just seems silly to kind of put a socket up above an attic, above a ceiling tile, just to have a patch cord go into a camera. Yeah. And that was frowned upon because that wasn't part of structured cabling. So he said, well, people are doing it, so we need to somehow figure out how to accommodate that. So we added MPTL, Modular Plug Terminated Link, to the standards and came out with a way to test it. Because the important thing is, if you're buying a cabling system that comes with a warranty, you need to make sure that all the connections and everything are good and pass performance specs. And the way that you would certify that, or the way that people were using their certifiers to test that, was actually not measuring the performance of the plug at the end of the link that would plug into your camera or your wireless access point. So we had to define the procedures and the equipment of how you could actually do this test properly and make sure the whole thing was measured and performed and passed certification. So, that was an example of something that came from the field, because people are going to do what they're going to do if it makes sense to them, even though it was outside the scope of the standards. So we came out with a new version to accommodate that and instruct people how to do it correctly. One of the things we're working on right now is extended reach or extended distance Ethernet. So a lot of people are probably aware that on paper, you're not allowed to go longer than 100 meters for a channel. But practically speaking, that cabling will support distances longer than that. And we know that people want to go greater than 100 meters. Sometimes it's just a little bit more. Sometimes it's a lot further. So we're working on a telecommunications service bulletin right now to address some of the things to be aware of if you want to run longer distance cabling. What are the best practices? How should you test that? What are the things you should look out for? What type of materials you should use? And so we'll see that. We expect that to be published later this year, later in 26. But there's already companies out there selling extended distance cabling solutions, which usually just means it's a larger wire conductor so that both your data signal and your PoE can go longer distances without being attenuated.
So, Dan, some headlines for our audience which are listening in. So, firstly, standards define how we connect and build structured cabling systems. We're talking about the infrastructure globally, and we follow these design guidelines. We've hinted to you that this thing MPTL, that means being able to crimp on a plug, not a socket, but a plug on the end of a cable has been defined, and that's been released. So we're aware of that. So important people are aware of that. We've also hinted that, hey, we can now take cabling further outside of the building, which is determined as extended reach, and it's become popular. So you're saying the standard CIA is now working on that to define those characteristics. What sort of challenges are you facing with extended reach?
Yeah, the main deal here is that as you go longer in distance, you have more signal attenuation, and whether something is going to work is really fundamentally based on the Ethernet chip that's in that device. So let's just throw out a number, 150 meters, 400 something feet. So will something work at a gig or not? Some devices might work, some might not, combinations of different brands. So the Ethernet chip that's going into that device is going to have a huge impact on whether it will work on that extended distance link. So one of the things is that these sort of become engineered solutions. And you'll see things where a cable manufacturer might say they'll support 1 gig at a specific distance, and a different manufacturer might say they'll support 1 gig at a longer distance or a shorter distance. And that's because their testing in their laboratories has determined that across a range of Ethernet devices, they feel comfortable at a certain length and warranting it. Now, what I will say is that this will not be a standard. It will be a TSB, which is an optional document. So it's a telecommunications service bulletin, because unfortunately, if something is certified to a 568.2 standard, that is, and it's tested, that's a guarantee that it will meet those performance requirements and it will work. When you get into these engineered solutions, you can't give that same level of guarantee. So what we'll do is publish best practices again, field testing recommendations, and sort of a matrix of things the user should take into consideration to determine whether or not it should work. Doesn't mean that it always will work.
Well, so let's read that back to our audience. So this is a key takeaway, because not only are we saying we could take our cable a little bit further, which was a known thing right back in the development of early structured cabling, some of those numbers such as 120, 150 were already known on shielded systems. So it's not unusual to know Ethernet could go that far. However, Dan hinted that the chipset was the defining factor. So obviously, as we go further to try and guarantee performance of chipsets, the price went up. So to enable lower cost performance and gigabit to be deployed across the world, they reduced the length. Now, as we go further, there's no guarantee. So you're just confirming, because there's no guarantees, a technical service bulletin would be potentially released to follow guidelines. I'm guessing not just the cable. Should we factor in the environment? So if you go extended reach,
Absolutely,
we need to consider containment, yes?
yeah, absolutely. So the largest factor in extended reach is attenuation or insertion loss. So that's the longer you go, the weaker the signal gets. That is a factor of frequency. So higher frequency signals will attenuate more. The length of the cable, the conductor size, the wire gauge. So extended distance cabling is going to be made from 22 or 23 gauge conductors, larger distance, but also temperature. So as temperature increases, the attenuation of a cable will increase. So one of the factors there is you're going longer distance, and if you're running this at higher environmental temperatures, the cabling, you might need to go to a high temperature rated cable. So most cable for commercial buildings is spec'd at 60 degrees Celsius, which means that its performance that's on the data sheet will maintain up to 60 C. But if you get above 60 degrees C, all bets are off. So there's higher temperature spec cabling that's rated up to 75 degrees C. So 60 C is what in Fahrenheit? That's 140 Fahrenheit, somewhere around there. And then 70 or 75 is going to be a bit hotter than that, which sounds ridiculously hot. But if you're in a hot environment and that cable is maybe outside in a conduit going to a camera or something, it's very easy that the cable in there could get up to those temperatures. So you have to consider the length, the wire gauge, the speed, and the environmental temperature. And that's going to change. So if I install and test that cable in the winter, it could very well pass. And the same cable in the summer might fail because all of a sudden the temperature has increased and therefore the signal attenuation has gone up dramatically.
So if we look at there's a chart, I believe, a temperature derating chart, and fundamentally all of the specs and standards we've been using in a product like a certifier, for example. So certifiers are key to testing infrastructure for connection quality, the cable quality, and looking at like an X-ray across that complete link. So, so most of their parameters are defined by, what is it, 20 degrees? It starts at 20 degrees. And
so your typical is 20, 23 degrees C, but up to 60. The certifiers, though, do not calculate or compensate for temperature. So that's up to the designer. So you're relying on the designer of the cabling system to look at their environment where the cables are being installed, and then understand that, okay, there's potential that that installation environment can increase up to a certain temperature. And then they would use a derating calculation to say that, okay, instead of 100 meters in this environment, we should only go 90 meters or 85 meters or something like that. So then they can choose different cabling that has higher performance capabilities if they need to go further in those hot conditions.
And does the standards team have a proposal as yet on how to manage that?
We published a white paper in December, which is just kind of an introduction to this topic. But right now, so I wrote the first pass of the field testing requirements or recommendations, I should say, because it's a TSB, it's not a requirement. And so that's now been circulated to committee. So the rest of the TR 42.7 engineering committee will start to make comments on that. And as these standards go, we go through different revisions and make technical changes and comments and edit it over and over and over. But our goal for this is to have something published, by summer or fall of this year, because it is something that a lot of consumers are eager to have. Because, financially speaking, if you can take those links a little bit further, it might just eliminate one extra equipment room that you have to install. It might mean that instead of running fiber with separate power, that you can run cable and PoE out to that piece of equipment that's a little further away from the equipment room than you would normally expect it to be. And this does affect PoE as well, because PoE is very greatly affected by distance and heat. Bundle sizes. So in our standards, if you're running PoE, we have recommendations on the number of cables that can be in a bundle when you're transmitting a certain amount of power, because if you have big bundles of cable, they can't dissipate the heat, and that also becomes a factor. It's a lot of stuff that people kind of take for granted, that it's always going to just work, and the environment is a huge factor in it.
Well, you also offer guidelines on containment, because a classic is we see the importance of security cameras and communication systems up in posts or poles. So we run a data cable outside of a building, and this is a typical deployment where extended reach is required, is we take a connection outside the building into, say, a car park or a security facility, and then it goes up this post or this pole, and it might be in an area or a region which gets hot. Will you cover that off, the containment?
So what you're talking about there, you have temperature to worry about, but you also have UV consider. So if you're taking a typical indoor cabling that's not meant for outside plant use, the UV is probably something you need to worry about, where the sun will deteriorate that jacket and cause it. So I would say generally you want to keep a cable in a conduit right up to the point of where it goes into a box and goes to that camera or whatever device you're running it to. Having that cable exposed to the environment, the sun's going to get to it. Animals can get to it. It's easy to cut if someone wanted to just take a camera out. So it should really always be enclosed in some kind of a protective conduit or other type of protection circuit.
That makes a lot of sense. So in summary, standard guidelines, we talked about MPTL and the current extended reach TSB that's planned. Is there anything else that the TIA is working on?
The thing we've been working on the last couple of years is single pair Ethernet. So if people aren't aware of this is an effort to go back to one pair cabling, and this is for low bandwidth applications, 10 megabit, maybe up to a gig. It's going to be shorter distances for the 1 gig, but for 10 meg up to a kilometer. And the idea here is for building automation systems or sensors, because so many systems in the building are being Ethernet connected instead of having all these different proprietary, serial protocols and other industrial protocols. So SPE has actually, the document's been produced, and now we're currently making updates to it. But this is one of these things where it's like, the cart before the horse. So you have the technology available, the standards are out there for single pair Ethernet, but then now it becomes a factor of when the industry starts to adopt it. There is a new connector for SPE, so you can use, people let's just use fire alarms or security alarms would normally use screw terminals, or for temperature sensors or things for environmental controls, you can still use a screw terminal, but there is a new connector defined. It basically looks like a fiber optic LC connector, but it's a 2-pin copper connector that is a copper LC connector, basically. So that's a new connector that's been defined for single pair Ethernet. And it's being adopted very slowly, but the technology is available. And so it's a matter of when do people start to make that conversion over. And you'll see more and more, smart building systems start to use SPE cabling going forward. So it's in the infancy, but it's out there, and we'll keep making changes to the spec and improving it and making it go longer or adding more distance to it. Adding more speed to it as we go longer. But it's an interesting one.
Wow, so that's 3 exciting topics. Can we also talk about? I noticed TIA talked about DCRU. Is that's something it's important? How is that progressing?
Yeah, we did update the 568.2 standard, so now it's the Echo revision. And previously, DCRU, so DC resistance unbalance, was only required for Category 8 cabling as far as being field tested. Now, all cables, as far as the manufacturers were concerned, had to meet a resistance unbalance spec. But for field certification, it was only required for Category 8. And the latest E version of the standard, that goes all the way back to Category 5E. So anything that's newly installed and certified, 5E up to Cat 8, has to be tested for resistance unbalance. And that's what that's looking at, is the difference in resistance between the 2 conductors in a pair and then between the different pairs. And this goes back to heat again, because if the cable resistance is uneven, you can generate more heat in the cabling, which will increase the temperature, which then increases the attenuation or the signal loss. So what you could have is a cable that is performing fine, but then you're putting a lot of PoE devices on there, and that cable heats up because of the uneven resistance. And then as the cable heats up, the insertion loss goes up, and then now all of a sudden you have data transmission problems. So it can be in the cable, but typically it's in the connections or the terminations. So we find most often when someone fails a resistance unbalance test, it's just the termination wasn't connected down well. Like punch it down again and it'll work.
So again, just to summarize for our listeners, thank you for joining us. So we've had a really, really great set of updates or tech bites. We're describing DCRU, which is recently made mandatory in the TIA. And what that is, that's a resistance test across each individual pair that certifiers must do, so only certifiers. And the key outcome, or the key background for that, is for the deployment of reliable PoE. So the idea of, if you were looking at deploying PoE reliably, particularly the 4-pair variety, once you go up to 90 watts, we really would require DCRU to be tested. So that's now that's now a mandatory requirement. Dan,
I will add something though, that our LANTEC 4 product that we've launched in 2019, it always has done DCRU, whether you've required it or not, as whether you've set it up or not. We always measure that. So you can have customers that have used the LANTEC 4 and maybe didn't select the standard to see if DCRU passes or fails, but you can just go back in our cloud and recertify that and see if installations you did several years ago actually meet the current DCRU standards for PoE. So that's, one of the nice things about always having all of the measurements run in that instrument is it's always testing everything. And when we do a pass-fail report, that pass-fail criteria is just on whatever measurements you select. So you can take a version D test and recertify it to version E and see if the PoE passes.
Well done to you and the team. Looking forward, that was a massive choice that's helped the industry, because now all those people which have done those tests can simply go and recertify. That sounds fantastic. We're about to wrap up here, so I hope our listeners have enjoyed that. So the key takeaways, once again, NPTL has been standardised. We're talking about extended reach and its PoE delivery. DCRU for certification is still critical when you're thinking about reliable deployment of power over Ethernet in a commercial network, and it's particularly preparing a site for 90-watt capability, whether you need it or not. Lastly, just a question, Dan. What are you seeing? Is TIA tracking the impact of AI? Is any kind of influence?
There's things we're working on. So when you're talking about AI data centers, that's where fiber really comes into play because of the bandwidth. So high density fiber, we'll see new connectors coming out. You're familiar with MPO. You can have 32 count MPOs, but there's a new connector standard we're working on, which is smaller than an LC, but it lets you gang them together to give you more flexibility. We are working on APC multi-mode connectors. So APC is the fiber connector that's at an angle, and usually those are used in single mode only because it reduces back reflection. So we're working on a spec for multi-mode APC connectors, specifically for MPOs and data centers. We launched OM5 fiber a few years ago. A lot of people aren't familiar with why OM5 exists. One of the key things with it is that it supports a wavelength that's 980 nanometers. So normally multi-mode fiber, you have 850 and 1300. So it supports 980, which is a new wavelength in the middle that's not being used much yet, but it does support that. And then one of the really crazy things is multi-core fiber. Wow. So this would be a fiber where you have one strand of glass, but inside that strand, there's multiple cores, maybe up to 6 or 8 cores in one strand of fiber. So it's a very high precision manufacturing method. And then of course, now you've got to terminate that or splice it. So let's say you're splicing multi-core fibers together. Now you've got to make sure that the different cores are lined up correctly when you splice them together or put a connector onto it. So those are further technologies that are being worked on to increase the density, get more data transmission into smaller cables. So there's a lot of stuff in the pipeline.
And Dan, what's your gut feeling? Do you have a prediction on AI now and where it's going for 2026?
The prediction is that, if you read the news and there's billions and billions of dollars being dedicated to building these data centers. So massive amounts of fiber getting installed. Obviously that needs to be tested and maintained. So even if you're not doing the installation of the fiber, these networks all have maintenance requirements and cleaning and inspection requirements. So, we know that all of our customers tell us they do at least a little bit of fiber. I think as we go forward in the next number of years, we'll see a higher shift to fiber versus copper. Frankly, copper for Cat 8, for example, is limited to 30 meters. And just when it comes down to the physics of it, to get more and more data on copper cable, you have to go to higher frequencies, which means the runs get shorter and shorter. So, I don't predict like a category 9 coming out, that's going to be 100 gig or something like that on copper. I think we'll we'll maintain copper for our 100 plus meters, 10 gigabits and less. But you start to move beyond that, you're going to definitely be shifting into fiber.
Right. So, Dan, we're going to wrap up now. Thank you to all our listeners. We really appreciate this because what we want to do is inform you, keep you up to date. Dan, we would love to invite you back. We've got a bunch of other topics to cover. So, once again, thank you to our listeners. And, Dan, thank you for that fantastic update. Please join us again on our next podcast. It is a series. We'll keep you updated. And, Dan, that was perfect.
Thanks, Gordon. Appreciate it.
See you again, and please check out the next podcast.
Wish yours did that? Time to go blue.